is Hasnul Hadi Ben Zakara. Together with my friend Haziq Aiman and also Fitri Hadi, will be sharing a few knowledge about Josephson Effect. So what is Josephson Effect? Josephson Effect is a phenomenon that happens when two superconductors are located in proximity and have some hindrance or restriction between them. Josephson Effect is an example of macroscopic quantum phenomenon where the effects of quantum mechanics can be observed at ordinary instead of the atomic scale. Furthermore, this effect also has practical application as it shows an accurate relationship between the different quantities of physics like frequency, voltage, and high accurate measurement. Other than that, the Josephson effect produces a current called supercurrent. This supercurrent flows continuously without any voltage across a device that is called Josephson junction. Next, the Josephson junction also has two or more superconductors along with a weak link. The weak link can be a thin insulating barrier known as superconductor-insulator superconductor junction, a short section of non-superconducting metal, or a physics constriction that weakens the superconductivity at the point of contact. Josephson effect is actually can be divided into two, which is DC Josephson effect and AC Josephson effect. Firstly, DC Josephson effect is related to the direct current crossing over the insulator when there is no external electromagnetic field present. This crossing over the absence of the electromagnetic field occurs due to Josephson tunneling. The DC Josephson current is directly proportional to the sign present in the Josephson phase, where the Josephson phase is a phase difference revolving across the insulator itself, which always stays the same and constant.
The AC Josephson effect. When there is a fixed cross around the junction, the phase and values for the same will alter linearly in accordance with time. Owing to this, the current will be a sinusoidal AC, aka alternating current, with a certain amplitude and frequency. This effect is mainly used for proving that the Josephson effect junction can also act as an accurate voltage to frequency converter. The Josephson effect can be used in many different areas. SQUIDS, aka Superconducting Quantum Interference Device, is a very sensitive magnetometer which works through the Josephson effect. Likewise, in meteorology, this effect will give precise conversion that takes place between the voltage and frequency.
Hello guys, my name is Haziq Aiman and my matrix number is 200984. Today, I'm going to share with you all something regarding to our presentation, regarding to our topic given. So, today in my part, I want to share with you all about quantum tunneling theory. You guys must be wondering, what is quantum tunneling theory? In physics word, quantum tunneling theory is a mechanical formula where a wave function can propagate through a potential barrier. In other words, quantum tunneling theory can only be explained by the wave nature of matter as described by quantum mechanics. If you guys still don't understand what I am trying to say, let me show you a little diagram to explain about what is tunneling theory. So, in classical physics, when a particle is incident on a barrier of greater energy, then the particle will be reflected. Whereas, when we treat the particle as a wave, like in quantum physics, the wave has a probability to exist within the barrier region and even on the other side. So, see this diagram to understand more. I hope you guys can understand what I explained briefly about the tunneling theory. So, enough about that. Let me introduce you about the history of tunneling theory. For you guys' information, quantum tunneling theory was developed from the study of relativity, which is discovered in 1896 by Henry Becquerel. Enough said about the history, let's dive into the application. Tunneling theory is the source of some of the most important microscopic physical phenomenon. Quantum tunneling has important implications on functioning of nanotechnology. In terms of electronics, tunneling is a source of current leakage in very large scale integration, also known as VLSI. This is the result of the substantial power drain and heating effect that plague such device. It is considered the lower limit on how microelectronic device element can be made. Tunneling is a fundamental technique used to program the floating gates of flash memory. If you guys don't know what is flash memory, this is a picture of it. Quantum tunneling is also an essential role during the phenomenon of nuclear fission. Quantum tunneling increases the probability of penetrating the Coulomb barrier. Even though the probability is low, the extremely large number of nuclei in the core of a star is sufficient to sustain a steady fusion reaction. Last but not least, the last application of quantum tunneling theory is scanning tunneling microscope, also known as STM. STM is invented by Gerd Binning and Heinrich Rohrer. A little disclaimer, actually there is a lot of application that has quantum tunneling effect that is brought to physics, but I only explain only 3. There are plenty of application more. If you guys want to know more, you guys can get a lot of info about quantum tunneling effect.